Welcome to the Data Hall YouTube channel. In this video, we are going to talk about how do we perform a one-way or two-way ANOVA in Stata. Now for this, we are going to load the reading data that contains the reading score based on along with different other variables, other categorical variables. So let's load this data. Now to load this data, we must have an internet connection and because we are going to load it from the Stata server. So let me show you this data. Now this data contains different individuals and their scores that they have secured in a reading test, and then what kind of a reading program were they in, what class were they in, and what kind of skill enhancement technique that was used. So let's say we want to check what is the impact of a program being in different program on the students' reading skills, or what is the impact of being in different skill enhancement technique on the reading skill of a student. Now for this, we are going to perform ANOVA, and in one unidirectional ANOVA and one-way ANOVA, we just have a single categorical variable or single independent variable whose impact we want to check on the dependent variable, the variable of interest. In two-way ANOVA, we have two different variables two different factors whose impact we want to check on our variable of interest. So do remember that one of the assumption of ANOVA is that the data is normally distributed, and for this what we are going to do is we are going to use histogram to check the distribution of our score variable. So let's create a histogram, and from the histogram we can see that the data is somewhat normally distributed. Again, let's create a histogram for each different category of program, and from this we can also see we have the density plot, and we can see that they are somewhat normally distributed. We can also create this based on different categories within the skill variable, the skill factor, and that also gives us some idea of the distribution of the data. So let's move to the one-way ANOVA or unidirectional ANOVA. To perform one-way ANOVA, we can either use the menu or the command. So let's give you the idea of where the menu is. We click on statistics, then we click on linear model and related, and then we have this ANOVA MANOVA option where we have this one-way ANOVA. And you can see that the one-way ANOVA is applied using the one-way command. We select the response variable and we select the factor variable and press OK. But let me also show it to you using the command. So what we do is, how the command is written is, we use the one-way command that performs the one-way ANOVA. Then we specify the dependent variable or the variable of interest, and then the factor variable. We can have an option of tabulation, but that is not necessary. So if we perform this one-way ANOVA, we get different statistics, but what we mainly are interested in this p-value. So the null hypothesis of one-way ANOVA is that the mean value of all the group is same. That is, there is no difference between the mean score of the different category, or what we can say is that the program didn't, for students in different program, they had similar score. So their mean for being in different program is not different. The alternate hypothesis is that mean of at least one category is different. That means that this program do have an impact on the score variable. So in this case, our p-value is less than 0.05. When our p-value is less than 0.05, that means that we reject the null hypothesis and accept the alternate hypothesis, which means that the mean are different. So in this case, our conclusion is that the program do have an impact on the scores of reading score of the students. Let's move to two-way ANOVA. The difference between two-way and one-way ANOVA is that in one-way ANOVA, we only have one factor, but in two-way ANOVA, we have two factors, and we have an interaction of these factors. So for this, we use the command ANOVA Now for two-way ANOVA, what we do is let's explore the menu from where we can perform the two-way ANOVA. We click on statistics, then move to linear model, then ANOVA MANOVA, and then there is this first option, which is analysis of variance and covariance. We have this new dialog box, and we know that the command that is used is called ANOVA. We select our dependent variable and we click over these three dots, and we select the main effect variable. Select whether it is continuous or effector variable. In our case, it is effector variable. Add it to list, and let's select. This was the dependent variable. Our independent variable is program, and then the second variable is skill. If skill was continuous, we would just check this box and add it. But let's perform this using the command. Commands are quite simple in this case. We just write the name of the command, that is ANOVA, then the dependent variable, and then our first independent variable. Along after two pound sign or hash sign, we write our second independent variable. Now what this pound sign would do is it would include this double pound sign would do is it would include the main effect of program, the main effect of skill, and then an interaction of these two variables. So let's execute this command, and what we can see is we have this main effect of program, which is significant, and that is the program does have an impact on score. Then we have skills. The mean values are different. We cannot say that there is an impact, but mean value is different for each category of the program. Then there is skill, which is significant at 10%, and we have the interaction of program and skill, which is also significant. Now there is another way of doing this. What we can do is write the command name, the dependent variable, the variable of interest, and the main effect of program and skill. And if we write a single pound, it would include just the interaction term. So this double pound would include the main effect along, these are the main effects along with the interaction term. But if we write it this way, then we have included the main effect by ourselves, and this would include the interaction term, just in case you are not interested in the interaction term. So if you execute this, we get exactly same answer as we did before. Now the null hypothesis and alternate hypothesis is similar. In the case of two-way ANOVA, we are comparing the mean of all the groups among themselves. So I hope this video was useful. Do subscribe to this channel and do hit the bell icon. Thanks for watching this video.